You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey, everybody. Welcome. I'm starting us off this week, and I'm going to talk a little bit, well, it's going to be a winding journey, but one of the things that a lot of people learned for the first time at the beginning of the COVID pandemic is that when you wash your hands with soap and water, you are not just physically removing the germs, but the soap actually kills many bacteria and viruses, including the virus that causes COVID-19, right?
Right.
So just a little chemistry here. It's not going to be too bad, I promise. So the reason soap...
I love chemistry.
Well, of course we do, but, some people get a little scared. It's okay.
I'm one of...
So the reason soap or
chemistry
detergent...
makes me nervous, I'm not going to lie. Sorry.
It won't be too bad. So the reason soap or detergent can do this is because of its chemical structure, and basically the soap molecules are shaped like a little pin or a sperm. It has a head that's hydrophilic. That means it's attracted to and bonds with water. And the tail is what's called hydrophobic. So it hates water, basically, and it likes to bond with fats. So when you use soap and water, some of the soap molecules form basically microscopic little tiny bubbles in the water. And the heads are pointing out and the tails are pointing in because the heads are the ones that like water. So bits of dirt actually get trapped inside the center of the bubbles and they get washed away. So actually almost, and I'm going to get to the part about how it kills bugs, but we're not there yet. Almost all living cells and some viruses like COVID have a cell envelope that is made of something that's called a phospholipid bilayer. And the actual chemicals involved are different, but the basic properties of one of these subunits that makes up the membrane is very similar to a soap molecule with a hydrophilic head and a fat-loving tail. But instead of a bubble, they form a double-layered sheet, and all the heads are on the two outer surfaces of the sheet, and all the tails meet in the middle. With me so far?
So far, so good.
Yep, I can picture that.
Rachel?
Flashbacks are happening, but I'm here.
Okay. So soap basically disrupts this membrane because the hydrophobic tails, the ones that like the fat, are basically trying to attach themselves to anything fatty and kind of wedge themselves in between the molecules of the envelope to get at the part in the middle. And in doing that, they break apart the membrane, and the microbe can't survive without it. And
it gets shredded apart, basically.
Yeah, all the cell contents are spilled out, basically. So the little broken bits are also surrounded by the soap, and they get washed away. Yay!
Ooh.
Yay!
So I've been studying microbiology this summer, which is very cool and interesting, and I've been learning a ton and not finding the material too difficult, except the immune system, which is my downfall. I find it very confusing.
That's fair.
Because it is confusing.
It's a confusing system.
I think even immunologists are confused about immunology sometimes, but scientific understanding of all the details of the immune system is not all that great even today. They're still finding out a ton about it. So my actual topic today, in spite of all the stuff I just said, actually
is not soap.
It's not exactly soap, but it relates to the immune system. Don't worry, I will keep things simple though. Okay, so a study was recently released that basically shows that human cells, just like any regular old cell in the human body, not the special immune cells, they actually use soap to destroy invading bacteria.
Our bodies are making soap to fight bacteria?
Well, it's not exactly soap, but it works like soap.
They use the same principle that soap works by.
Yeah.
Okay, cool.
So immunologists, they already knew that these kind of like regular Joe cells of the body could defend themselves somewhat once they were given a kind of an alarm signal by special immune cells. Okay. What they did not know was what the mechanism was that these cells used. the regular Joe cells. So it turns out that when a bacterium, like, for example, salmonella, salmonella makes you sick.
Okay.
Oh, yeah. As a naturalist, a few of us have been there.
Yeah, oh boy.
Chicken, man.
Reptiles and amphibians, you guys carry salmonella
Okay.
and birds. So
Yeah, I went for chickens.
And we know Rachel likes to poke dead things with sticks.
I do. It's fun. I have pictures.
don't we all though?
I should share them.
So anyway, when salmonella invades a human cell, I'm just gonna leave that right there, Rachel. Just not gonna.
I know. Oh,
I do.
jeez.
I have pictures of when I poke
You don't
things
sound-
with a
you don't
stick.
sound at all
Things that are
psychotic
dead.
when you
I
say
poke
that,
it with
you
a
know,
stick and I take a picture.
You want to see my pictures of when I poked at that animal?
Not scary at all.
Yeah, no, it sounds totally normal. Go on, Victoria.
Yeah.
You,
So
I know
with
you've done it.
salmonella-
It's fine.
Salmonella.
Salmonella.
When it invades a human cell, the cell basically makes two molecules to help itself defend. So one is kind of like a wedge that breaks open an extra outer membrane that it makes salmonella and some other types of bacteria kind of hardier. And so then that wedge lets in the second molecule, which is like the soap. It lets it in to break up that inner layer of the membrane and destroy the cell by the process that I described earlier.
Okay.
Awesome.
So if you were paying close attention, you would have heard me say earlier that pretty much all organisms have cells with this type of membrane.
What?
Mhm.
What don't?
Well, the question is, I mean, we're not going to get into what don't. I think it's mostly archaea,
Oh.
but
All right.
that's like a whole other road. But the question is, how do human cells avoid destroying themselves with the
Right.
soap?
Yeah.
So it turns out,
And how do your hands not fall apart when you put them in soap?
well, yeah.
That's
I mean,
what
the
lie
other
is
thing I'm
for.
studying
Kirk.
is anatomy, so I could tell you about that, but again, that would make this episode way
Another
too
episode.
long. So it turns out these molecules, these soap-type molecules, specifically target types of fats that are only found in bacterial membranes. And also, you probably know about cholesterol as something that's bad for you, but cholesterol is actually a vital component of your human cell membranes, and it blocks the action of these molecules. So the body is the body's amazing. That's what I have today. Oh, also, this study that I am quoting or talking about is in the July 16th issue of Science, and it is called "A Human Apolipoprotein L with Detergent-like Activity Kills Intracellular Pathogens," and it's by Ryan Gaudet and his colleagues.
So our bodies are making detergent to clean themselves.
Yes.
Super
so you
cool.
could say that our bodies are changing the tide on that bacteria.
Oh,
That was pretty bad. Okay.
wow.
And you can hear from Kirk after the break.
Yay!
You can. And will.
And will.
If you're listening to this podcast, you are at least a little strange by nature, just like us. Why not make it official? We're happy to announce the launching of our Patreon program, and it's called The Society of Strange. You can join today.
You may have noticed we've been experimenting with not having ads on the show lately, and it has been great. But while we're not doing this for the money, doing a podcast like this can get expensive.
We have web hosting fees, there's audio hosting fees, equipment fees. It all really adds up. By joining the Society of Strange, you can help us sustain the show and get some perks as well.
All Society of Strange members get one of our swanky new water bottle stickers, and at higher levels of support, you can get secret bonus content and even our studio voicemail number.
Oh, yes, excellent. You can check it all out at patreon.com/strangebynature.
So I'm going to take you on a little journey here. We are going back to the year 1660. And Joshua Chowdhury wrote something called the Britannia of Baconia. Now, while that sounds like a treatise on the delights of British bacon, it's not. The subtitle of the book perhaps will give us a bit more. So here we go. This is the subtitle of the book. The natural rarities of England, Scotland, and Wales, according as they are to be found in every shire, historically related, according to the precepts of the Lord Bacon, methodically digested, and the causes of many of them philosophically attempted, with observations upon them and deductions from them, whereby divers secrets in nature are discovered, and some things hitherto reckoned prodigies are fain to confess the cause whence they proceed, useful for all ingenious men of what profession or quality soever.
That's the
I'm now more
subtitle.
confused.
It's quite a subtitle. Yeah,
That's
it's quite a
longer than the
subtitle.
title.
Paragraph.
Yeah, I know. That's how they used to do it back in the days. So he was basically trying to write one of these epic tomes that covered all of human knowledge. He was a big supporter of Francis Bacon. That's the Bacon reference.
Baconia.
So he wrote the following passage in this tome. There is another thing which I recommend to the observation of mathematical men, which is that in February, and for a little before and a little after that month, as I has observed several years together, about 6 in the evening, when the twilight hath almost deserted the horizon, you shall see a plainly discernible way of the twilight striking up toward the Pleiades, and seeming almost to touch them. But what the cause of it should be, I cannot yet imagine, but leave it to future inquiry.
Okay.
So it's you kind of go, wait, what? What is he describing? Well, what Chowdhury...
I got excited about the Pleiades.
Right.
They're my favorite star group.
Nice. Well, what Chowdhury was describing had been observed for centuries before this around the world. So by no means did he discover this phenomenon. It may at first blush sound
Never
like he's
seen
just
that
describing
before.
the light of twilight, which is like, woo, big deal. In other words, the light that's coming over the horizon. But this is actually something very different and very, very strange. This is a light that appears in the sky both before the true light of dawn and after the twilight of sunset. So this light appears in a slightly different part of the sky, actually, than the actual light of the sun. And it is not light from the sunrise or from the sunset. Yeah, now there are oral traditions around the world that describe this light, including notably those of Islam. Tradition holds that the Prophet Muhammad described this false dawn actually to warn people about when to properly pray. So Muslims were to pray at true dawn, when the very first light of the sun is visible, or what we might call astronomical dawn. And writings and oral traditions pointed out that there's another light in the sky, and people should not confuse them. This strange light was also noted by the ancient Egyptians, and they noted that it made a pyramid shape in the sky. And we know they're real big on pyramids. And they also noted that the angle of this pyramid in the sky would shift throughout the seasons. Pretty weird, right? Yes. Now, you've probably never seen this, but probably because we live in pretty light-polluted areas. In modern times, we call this strange light in the sky the Zodiacal Light. It's called the Zodiacal Light as it seems to always show up along the same path as the zodiac. And the zodiac is the path that all the planets in the sky are also found along. And this is actually a good clue that we are seeing something that has nothing to do with our atmosphere, like sunrise and sunsets do, but rather has something actually to do with space. So the astronomer Cassini, who's a fairly famous astronomer, he wrote not that much later in 1683 that the zodiacal light must be made of dust in space being lit up by the sun. That was his conclusion. He observed that as you move closer to the equator, it gets brighter, and the dust must be flattened, be like a flattened cloud in space. And so when your line of sight gets closer to the viewing the cloud edge on, as it would be at the equator, you're seeing more of that reflected light. That was his theory, and we've long basically known him to be correct, that this is dust in space being lit up by the sun that we can see just before dawn and dusk on Earth. And some astronomers thought maybe it was like leftover dust from the formation of the solar system, right? And some thought maybe it had been deposited by comets as they were circling the sun and breaking up. Both those things would leave dust in a flat sort of disk around the sun, in orbit around the sun. Enormous amounts of time went in over the last 400 years or so, people trying to calculate and conjecture which of these theories are correct about what could be causing this strange light in the
bizarre.
sky.
We
Finally.
We found out.
Finally, this year, we have what I
Wow.
believe is the definitive answer to the mystery of the zodiacal light. On March 9th of this year, the Journal of Geophysical Research published the paper, Distribution of Interplanetary Dust Detected by the Juno Spacecraft and Its Contribution to the Zodiacal Light. So, this blows my mind because it's a bit of completely unintended science. This spacecraft did not set out to solve this mystery. It actually was on its way to Jupiter, and this was not something they set out to try to figure out. Researcher John Leif Jorgensen had put a camera on the spacecraft that was supposed to look for unknown asteroids. To figure we're out here where it's really dark, let's throw a camera on there and maybe we'll detect something we didn't know was there. That'd be pretty cool. Might as well do it, right? So they put this camera on there, not expecting that they'd really detect much of anything. When they started to download the images, though, there were thousands of unidentified streaks and specks in these photos.
Yeah.
And the team was just like baffled.
What?
Like these should not have been there. So they did measurements, though, to figure out, like, oh my gosh, what are we seeing? And they discovered that these were not new asteroids. They were actually just teeny tiny specks. And what they discovered was that there was these little teeny tiny specks of dust that were traveling at approximately 10,000 miles per hour. And they were essentially sandblasting the solar panels of the Juno spacecraft.
Oh my gosh.
And the camera was actually picking up tiny pieces of the craft being blasted away by all these impacts from the dust. Now, these particles can remove 1,000 times their own mass when they hit something because they're going 10,000 miles an hour. Luckily, very luckily, they have extremely small
they're
mass to start with.
Okay.
Right?
They're
so
still
they're not
going
just like destroying
10,000
the whole
miles an
spacecraft.
hour.
Yeah. But they
my
are basically sandblasting it as it hits it. And this camera was picking up little flecks of like the solar panels and stuff being ablated off. So they said, hey, this is an opportunity. And they mapped where the craft encountered dust and where it didn't encounter dust so they could figure out maybe where this dust was coming from. And it turns out the dust is primarily found in a band that is 2 astronomical units from the sun. So I got to explain what that means. An astronomical unit is the distance from the sun to the earth, right? So the source of the dust seems to be twice the distance from the earth to the sun. Do you
Okay.
know what is twice the distance away?
Saturn?
Not
No.
that far.
Well, it's not as far as Mars, is it?
It's
Really?
almost exactly where Mars is. Yeah.
Okay.
Mars is about 2 AU away. And we know Mars is the dustiest planet in the solar system. Well, it turns out that some of that dust seems to be
What?
leaking into space.
Wow.
That's how dusty it is there. When we see the zodiacal light in the sky on Earth, we're seeing dust in space being lit up by the sun, and that dust was once on Mars. It blows
That's
my
so
mind
cool.
how cool this was. The big question for researchers now will be how exactly is the dust getting off the planet, right? Because that's equally bizarre.
Because Mars has
now,
a pretty, like, it doesn't have quite as strong a gravity as
It's
Earth.
a pretty
but
decent
it's like,
gravity.
I don't know,
Yeah.
7/8 of it or something.
yeah, oh yeah. It's still got gravity. The atmosphere is not as thick, and we do know there are huge dust storms on the planet that kick up dust, but they should not be
Yeah.
reaching escape velocity.
Right.
and leaving the planet, right? So it's like, the mystery of where the zodiacal light comes from is, I feel, has been pretty much definitively solved at this point. But how the dust is actually getting there is still a mystery that now scientists can really dig their teeth into. I will say, too, if you want to try to see the zodiacal light, it is easier to see the closer you are to the equator, but you really can see it anywhere on Earth. You can look to the east in the pre-dawn sky. Probably some of the best times, I say, is sort of late summer, early autumn. Or if you're more of a night owl, you can look at the western sky at dusk in late winter or early spring. It can be seen year-round, though, and the darker the skies, the better. You basically have to have no light pollution whatsoever. Because if you've ever seen light on the horizon from a nearby, the next town over, that's kind of what it looks like. So you need to be somewhere where it is absolutely pitch black
That's so
outside.
cool. I have never heard of a zodiacal light at all, which I feel like is surprising because I feel like it's the kind
I've
of thing
not
I
heard
would
of
have
it
heard
either.
of.
That's crazy.
Thank you so much. That was really, really interesting.
It's so cool. And the fact that this new research was an accident that they basically
That's so cool.
figured out where it was coming from is such a cool example of researchers having that inquisical mind and seeing something and being like, you know what, I'm gonna run this through and figure out what's going on and just making new discoveries, which is awesome. It's what science is all about. And when they are strange discoveries, I love it even more. Coming up next after the break, we have Rachel.
Well, this week we've talked about small dust space particles that apparently are being shimmered more or less in the light of the sun.
Shimmered. I like it.
Little shimmer.
Sure. Yeah.
We talked about our immune system of our body. So I'm going on the opposite of all of this, and we're going to China, where
China is the opposite of space
no,
dust and immune soap.
No.
It's something in China.
That makes no sense.
We're going size-wise. It's
Okay.
going to China, and we're going to look at something big.
I'm sorry. We'll stop harassing you and let you do your topic.
So I'm talking about Andreas David. Try it again.
Doesn't sound like a Chinese name.
I'm going to say the Latin name of this animal. The Chinese one I'd actually probably be better at. I took Chinese. Very long time ago. Okay. Andreas Davidinus. That's fine. Also known as the Chinese giant salamander.
Oh, yes.
Yeah.
Oh, I love this.
All right.
Oh, my
so
gosh. All right. Lay it on us.
I'm going to get this part out of the way. This animal is critically endangered. There's not that many or a lot anymore. They're used in traditional Chinese medicine. They're considered a delicacy. There's been a lot of habitat loss for this particular animal. It's even been introduced similar in Taiwan, introduced species in Taiwan. There's a lot of habitat loss and pollution and because of all of these. It's a critically endangered species. However, it is so cool. It is considered one of the largest salamanders on the planet.
Lace your boots up. Your
it's
socks
so
are about
big.
to blow clean off.
How big is it?
How big is it, Rachel?
It can be bigger than me. The average adult salamander, at least in Minnesota, the ones that we have, they're about 6-7 inches, maybe. The big ones,
Max.
The
massive,
big ones,
right?
yeah. Some of the smaller
It's
ones, like
max.
3 inches. Yeah.
That's it. These guys, they get to be,
And gals.
the average is 3.8 feet in length.
Amazing.
So big.
Amazing.
Also known as 1.15 meters. They can reach 5.9 feet in length, which is larger than me.
Amazing.
That is longer than I am tall. The salamander's bigger than me. And it could be weight anywhere from 55 to 66 pounds or up to 110. The biggest one they've ever had was 5.9 feet, and it was 59 kilograms or 130 pounds. So that's largest by weight and length, actually.
Gotcha.
Yeah.
Oh, how long did you say the biggest was?
5.9 feet.
5.9.
Yeah.
Oh, okay. I'm sorry. I thought you gave a
No,
different number
it's the
than you did
same.
before, so I was confused.
Giant
Okay, good.
giant salamanders. What's up? So what it looks like, it has this large, broad head with really small eyes that are forward facing, more or less. It's really dark. It's this large head that it has is flat, broad, has a really wide mouth, just like a traditional salamander, like a tiger salamander or a blue spotted. A lot of people mistake salamanders for lizards. They are not. They are amphibians. They have a 2-part life cycle. They do look very similar, but they have a tadpole version. Not quite a tadpole.
Right.
Yeah.
It's a good sort of analogy.
We're gonna
You
go
can
with the
call it a
tadpole.
tadpole.
It looks a lot like an axolotl. It has these little external gills around its head.
Right.
And most salamanders then leave the water, but not the Chinese giant salamander, which is an aquatic salamander. It stays in the water for its entire life. So it has really wrinkly skin, a really wide mouth, and it actually has a dark brown mottled pattern that helps keep it safe and camouflaged. But also, fun fact, it secretes a sticky white secretion to repel predators.
I bet that tastes good.
100%. Sounds amazing. Don't totally want to taste that. But they also are known to vocalize. They make noises.
Oh, really?
Oh,
Like barking,
Wow.
whining, hissing, or crying sounds. Some of
I want to see one of these in
So
person
bad.
so bad.
some of these vocalizations sound very similar to the crying of a young human child, which
you may be hearing that in the
there you
background
go.
right now.
Wow. Do you have giant salamanders in
why
your
haven't we
home?
seen it?
No,
Yep.
but I do have 2.5-year-old twins.
But that is why in the
Same
Chinese language they are also known as the infant fish. Crying infant fish, because they sound like
Cool.
a crying human child. These guys, generally speaking, feed on insects. They will eat horsehair worms, amphibians, frogs, other salamanders if they can catch them. They eat freshwater crabs, fish, shrimp, and the Asiatic water shrew. Horrifying. Generally speaking, these salamanders live in rivers. They all have their own territories that they maintain. And that is part of the reason why they are so critically endangered. It's because of where their habitat is and what their ranges are. They were once really widespread in western and southern China, but now it's super fragmented. So because of that, it's really hard for them to get from place to place to breed. Generally speaking, they are like in the basins of the Yangtze, the Pearl, and the Yellow River as well. And there's a lot of water activity on those and a lot of dams, which causes issue if you're a salamander who's generally aquatic. You're going to stay in this general same spot. You go to find somebody else to breed and you can't because there's dams and water traffic in your way, and you're a large salamander and you can't see that well either. Just like a lot of other salamanders.
I seem to recall hearing too, like one of the problems was that they were, people were wanting to like catch them and whatnot for this medicine or for food and whatnot.
Yes.
And they said, no, you can't do that anymore. So people started farming like the Japanese and the Korean varieties in China in large numbers. And then the government said, no one's allowed to raise salamanders anymore. And so the farmers all let them all go into the wild. And so all of a sudden there was all these introduced salamanders that took up the same habitats, and there was either interbreeding or a competition. And I heard that was been a big challenge for their survival as well.
That's also a pretty big problem for them. Some of the articles that I was reading did mention some of the farming that was going on. but I hadn't quite heard that part as the release. From what I've read, there's a lot of confusion on what is different between, there might be 5 different types of Chinese giant salamanders. They're trying to figure out if they're different from the Japanese giant salamander or not, but because of all the farming and the introduced species, there's not enough habitat, and there's some interbreeding, so they're not really sure who is where and who is what. So,
Right.
sounds like a
real mess.
disaster.
Yeah.
But like I was saying,
Yeah.
the Chinese giant salamander is an entirely aquatic species, and it lives in rocky hill streams, and it needs clear water. So, generally speaking, the rivers that I was talking about are fairly polluted just because of how trafficked they are. They live in the dark,
Yeah.
rocky crevices along the bank, which is where a lot of people will build their homes and build docks and things like that. And there's one isolated population in an altitude of 13,800 feet in the Tibetan plateau.
Wow.
We're not sure where
fairly
exactly, or whether or not it's a giant salamander technically, or if it's a different species, or if the particular habitat supports it.
Huh.
Because of pollution in the Tibetan plateau, because they do prefer to live in streams with a small width as well. Super shallow, things like that.
Oh, sure.
There's been some pretty big issues with that, as well as you were talking about the release of the capital brev giant Chinese water salamanders, Kirk.
Right.
In 2011, there were 8,000 released. Yeah.
Oh man, yeah, that must have been what I'd heard about. That's
Oh boy.
that's pretty tough.
Makes
Don't
people
get
dumping
me
their
started.
goldfish into the local lakes seem
Don't get me started on
relatively
goldfish.
minor.
Please don't.
Don't do that though, folks. Don't
Yeah,
do that.
because they introduce a lot of diseases, and they're from the farms and everything. It's just to leave us on a happier note. Everything has been issues, but there's been a lot about climate change and habitat destruction. Happy topics.
Everything is awful.
Everything is awful.
Yes.
Everything is cool when the world is going away. Anyway.
Wow. Welcome to the dark episode of Strange
So there
by
are a
Nature.
lot of conservation efforts that are
Bring
happening.
us back up, please. Bring us back up.
They are moving more in the direction for normalization, trying to there's a lot of nature conservation efforts actually that are happening. There's environmental protection laws that have been put in place to help. Part of it is to help the ecosystem and the habitats and the communities that are there as well. There are quite a few, where there's more than 14 nature reserves that are established for the conservation of the Chinese giant salamander on their own.
Very cool.
A lot of these things have been working to save the Chinese giant salamander. They also have the largest breeding and protection base is what I mean for this salamander in China, and it's to breed the amphibians for scientific research and the Chinese traditional industry, as well as aquariums, so they're everywhere so you can see them, and potentially introduce them back into the wild as long as, it's safe. So we can save the world's largest amphibian from extinction as part of it. Overall, they're so cool. And the fact that they have a fun toxic secretion, that they get to be so big, bigger than myself, crazy. Is amazing. The breeding season actually is happening right now as of the recording. Not to put a date on it, but it is, in the summer. Between, July and September. That's when mating occurs. So that's fun. That's happening now. Maybe, hopefully there'll be lots
There's
of...
salamander loving going on.
There's salamander loving going on. Hopefully the 400 to 500 eggs that get laid, live. Fingers crossed. That's what I have for you today.
Yeah.
Well, super cool topic. Thanks, Rachel.
Yeah. Anytime. Glad to bring us down.
Stay
We'll talk
happy,
to everybody
everybody.
next week.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.